Hello, everybody, and welcome to Altair Insights, a podcast where space meets business. This is your host, Nicholas Chinchaladze, and I have my colleague here, Martynas and we have a very special guest today. Jamie Herring is the CEO of Climate Engine, a Google Cloud partner company focused on using satellite data to build economic resilience to planetary change. In this capacity, he has worked with major corporations and financial institutions around the world. Prior to this, Jamie was the executive digital producer for a variety of climate data products for organizations such as the World Bank, NOAA, NASA, the Gates Foundation, the White House, and the World Resources Institute. Jamie holds a Ph.D. in natural resources and information sciences from Cornell University. So nice to have you, Jamie, and welcome to our podcast.
Yeah, no, thanks for having us. Really happy to be here. Thanks, guys.
Perfect, no problem. So let's dive, I guess, into the questions. So, and the first one is the obvious one. So could you walk us through on how Climate Engine's endeavor began and what clients are you serving?
Yeah, sure. So, well, it's not a super simple question to answer, but Climate Engine was formed in 2014 out of the Desert Research Institute, which is one of the premier research institutes around hydrological research. And it was actually funded through Google through their Geo for Good group, which is, a nonprofit organization at Google that supports earth sciences and a variety of geospatial for good products and projects. So Climate Engine, started there. We aligned ourselves early with Earth Engine, Google Earth Engine, which is, the world's leading geospatial platform for processing space-based data, really, and creating models based on the space-based data, and really leveraging cloud. Right now, it's really the really big sort of shift, I think, back then was, using cloud technologies to run these massive parallel processes to get insights from the space data. So that's how it started. And then a couple of years ago, with some colleagues at Google, started talking about how this data could be used in a commercial context, right? So traditionally, Earth Engine and Climate Engine, we serviced a lot of nonprofits, a lot of government groups. But there were a lot of discussions around really the need to bridge this data between the economic world and the environmental world. And that's really been a massive challenge, over the course of, economic history, right? It's always been sort of diametrically opposed in some ways, right? The environment versus the economy. And really, collectively, between folks at Climate Engine, folks at Google Cloud, really started thinking that bridge needed to happen, right? We needed to better attribute risks to the economy that the environment was posing, and vice versa. What risks the economy was posing to the environment. So that really was the genesis of the commercial side of Climate Engine and the commercial side of Earth Engine within Google Cloud.
Don't miss one of the biggest space industry conventions this year. Attend the International Space Convention and get exclusive 3-day access to over 100 space industry leaders and experts discussing over 95 topics, including space sustainability, Earth and deep space observation, commercial space travel, cybersecurity, space law, funding opportunities for emerging space startups, and other topics. Click the link in the description to get your ticket. See you at the ISC.
Thank you for that insight, Jamie. Obviously, this is 2014, so it's been good years, some good years that you've been active right now. And we obviously following the growth as we discussed. We found you across these public mediums out there, so we thought to have this insightful conversation today. Some questions that again I have from my side. So first of all, sure. I want to read something through, which is very short. So according to the Intergovernmental Panel on Climate Change, which is called IPCC, since systematic scientific assessments began in the 1970s, the influence of human activity on the warming of the climate system has evolved from theory to established fact. right? So now it's not a theory anymore. I mean, it's a real threat. We're talking about a real change in terms of the climate. So now speaking about, again, climate engine. So maybe you can talk about, and my question is, how does satellite generated data can help transform someone's organizations, private companies, kind of life, right? And improve the decision making, evaluate opportunities, and build more sustainable planets on top of that as well.
Yeah, no, happy. Yeah, thanks for that. I mean, that really strikes at the heart of why Climate Engine decided to go commercial a couple of years ago. So, my background and my history in working, I work with the IPCC, I've worked with the World Bank, as you mentioned earlier, all these different organizations, really focused on traditionally what's been understood as climate data, right? Which is really these long-term projections, right? You hear about these scenarios, these under a, 2 degrees C emissions or 3 degrees C, you hear that all the time, right? And you hear, by 2050, by 2070, 2080, all these bad things are going to happen, right? So I worked in that space probably for about 15 years and felt really committed to getting that information out, right? And building systems and building data products to get people to understand what the actual risks are long term. But I think, a few years ago, became pretty disillusioned with that in a way, right? And started thinking about, well, despite knowing this, right, despite the IPCC being around, for decades and publishing this research, the actions being taken to combat climate change are nowhere near what's required, right? It's just really scratching the surface. Like we're, despite all this work, all this research, all this effort to get those long-term climate projections into the public consciousness, greenhouse gas emissions are still going up, right? And in some cases increasing, right? We start seeing these different increases, averaged out over the past decade or so. So that really got me thinking that, one of the major problems with climate is that we don't experience climate in the future, right? We experience it in the day-to-day, right? And I think we as humans, we're not very good at long-term risks, right? We're really, really, really good at short-term risks, right? So COVID being a great example of kinds of things that we collectively can do, as societies, as economies, to reduce risk, right? So I'm Canadian. I live in Canada. 4 years ago, if someone said, hey, the Canadian government was going to close the border to the US, I would have thought you're crazy. Never in a million years, is the Canadian government going to close the border, right? Or that border going to be closed, let alone the Canadian government actually doing that, right? Lo and behold, 60, 90 days in the pandemic, borders closed, right? So we can do these things, right? We can harness resources. We can actually change socioeconomic systems on the flip of a dime. And so those two things kind of got me thinking about, well, if we need to take action, and we do obviously desperately need to take action on climate, how can we leverage the day-to-day data, right? And that brought us into the remote sensing, right? So right now, there's billions and if not trillions of dollars being lost in the global economy to these climate threats, right? With the flood, wildfires, hurricanes. You hear these things all the time. You see them all the time, right? We're hitting, record temperatures. And I'm assuming you guys are in Europe, where, okay, you guys get hit by these crazy heat waves, right? And that has not only health effects on human beings, that have impacts on economic production, has impacts on food production. There's all these sort of tag-on sort of impacts. For the most part, we don't know what those impacts are until well after the fact, right? There'll be a study, there'll be a thing 2 years from now, hey, this heat wave caused X amount of economic impact, blah, 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 right? So it's still sort of lagging in terms of us being able to do anything about it, right? It's like, well, yeah, interesting, but okay, like that was 2 years ago, right? So that's really where, in my mind, where remote sensing becomes a central piece of climate data. And that's really what we're trying to do, is try to bridge that gap, right? And really attempt to use these technologies and cloud-based processing, not only to understand what the economic risks are today, because they are today, they're happening as we speak, right? But using, the best of the world's available science to start to predict these impacts, right? So what can we predict are going to be the economic impacts of climate events today, but also, climate events in potentially 1 week, 2 weeks, 1 quarter, right? More like economic sort of timeframes that are much more actionable. And that's really what our mission is to deliver that best available science, and working with, some of the best economists, the best financial people in the world, to start creating these predictive analytics. And really our hope is by doing that, we can actually start, moving the needle in terms of climate resilience, right? Because if people start feeling it, they start understanding what the impacts are today, they can take better actions.
For sure.
Perfect. So thank you, Jamie, for sharing again and pointing the scale of the climate change and the implications that it has on different industries. And again, luckily we have companies like Climate Engine who's working to, again, detect the changes that are happening, monitor that, and help the adjacent industries to make better decisions in terms of how to adjust to that. And speaking of the Climate Engine, so those are 6 different sectors that your company is working across. So it's agriculture, finance and economics, supply chain and consumer goods, professional services, infrastructure and transportation, and public sector. So let's talk a bit more about agriculture. So, for example, how can farmers improve yields and better predict agriculture outputs by combining spaceborne data sources and land sensor measurements?
Yeah, I mean, that's a podcast in and of itself. That's a big question. There's a whole number of different types of sensors that are available, and different types of insights, from data sets, like water availability, water use. I mean, those are some really, really big use cases. Understanding sort of climatological shifts and drought, right? So understanding drought impacts, all the way to like actually understanding productivity, right? And so there's a whole sort of range of different types of data sources, and different types of uses, right? So like I said, I mean, that's kind of a podcast in and of itself. What we're doing, which is a little bit different, we don't work directly with farmers. There's amazing companies that are out there doing that type of work. Drones are another way, and I think a really big innovation towards getting imagery, right, to start understanding where these shifts are. What we do is we're focused mostly on using public data sources, right? So Landsat and Sentinel, and harmonized Landsat Sentinel. Those are kind of the 2 main sensors that we use. But really what we're trying to do, which is a little bit different, is use those sensors and then start to understand and laddering up the impacts, the macroeconomic impacts, right? So both at sort of local, hyper-local, field level scales, then regional scales, right? So like areas, whether it's a county, a city, a province, a state, whatever those might be, and laddering those up to macroeconomic indicators. So, and that's really useful. So one important thing is it's hard to kind of silo these things into these different groups, right? We try to, but those agricultural indicators are really important for supply chain, right? Which then have knock-on effects to transportation organizations, which have knock-on effects to public sector, right? So it's really when we talk about agriculture, we talk about the things that we're interested in looking at, is really using these sensors to understand yield, understand risk, right? Where are those risks? Where are droughts happening? What are those potential impacts of the drought? But it's not specifically delivered to farmers, right? There's all kinds of companies that do that, but rather laddering that out to economic indicators, right? So policymakers can understand, hey, oh wow, okay, we've got these really severe droughts to these types of crops, right? We work with like railways, so that they can understand, hey, like where we normally have all our cars, this season, there's going to be no grains, right? So instead of taking, a multi-million-dollar loss on like, shipping all your cars in one location, don't send as many there, send some over here, right? Because over here we have like historically high yields, right? So it really is, in my mind, creating these bridges of data between sectors to build resilience. And the two sort of main concepts, and I know we're kind of straying from agriculture a little bit, but it's related. The two main concepts that we use at Climate Engine are economic resilience, financial resilience, and operational resilience, right? And what we mean by operational resilience is that, we've built all our economies, all our social structures, all our infrastructure based on this idea that climate is kind of stable, right? The future kind of looks like the past, which is kind of a given, right? It was like, well, it's kind of, here's the boundaries and we'll build our stuff around that. And we haven't really thought about that too much. But now we know that idea is false. It's completely false, because the future is absolutely not going to look like the present. The present doesn't even look like the past, right? Let alone the future. So when we talk about, things like agriculture, understanding where these shifts are happening, it really is at sort of a macroeconomic level that we need to start doing that, because we're going to need to figure out how to move all our resources around to adjust for these changes. And so really that is what we consider resilience, right? It's not so much, hey, we got to build this bridge this way, we got to move this city over here. That's all really important stuff, absolutely. But I think what we need to start doing on top of that is understanding how to manage the chaos that we're experiencing now, and honestly, the chaos that's to come. So anyway, I know that's a bit of a stray from agriculture, but that's how we think about agriculture and how we use the spaceborne data to help with that.
I absolutely agree with you, Jamie, and the fact that obviously the present doesn't look like the past, and obviously the future is not going to be the same as was in the past. So we're kind of taking this as a given, as you mentioned. But we see now a lot of changes and changing in precipitation of patterns in agriculture, the temperature patterns that are rising, floods, droughts, changes in crops and livestock viability, new pathogens and weed problems that are rising. So what would you say, out of the six, what would be the biggest threat to in the near term for the agriculture sector? And we can sum up the agriculture side with that.
Oh, the biggest threat. There's so many. It's hard to nail just one. I think variability, right, and the extremes. I think those are, and those kind of hit upon everything you mentioned, right? So it's not just one specific thing. I think it's
everything together.
Yeah, it's it's the variability of those things, right? You might have one bumper crop for 2 years and think, hey, everything's great, and then all of a sudden a shift, and then all of a sudden there's new disease strains. There might be a new invasive species, and sort of the combination of these things. And that's honestly what scares me the most, is not that, hey, we can't adjust to a drought, right? There's droughts been historically all the time, right? But it's rather like, having these things piled onto each other. We have a massive drought. California is a perfect example. Massive mega drought, wildfire, those wildfires stripping away, trees, which then make the land more susceptible to mudslides, flooding, right? So it's the combination of these emergency events that you start seeing in agriculture specifically as well, that I think is the piece that keeps me up at night.
Got it. Yeah, well, those are substantial problems, and obviously having a company like yours that can provide those insights and the data to make better decisions and kind of predict things before they're going to happen. I think in this day and age, to make those quick decisions before there's a problem, it's really good to have. So one of the 6 things that we have, including the sectors that you serve. So as Nika mentioned, agriculture, and we talked about that briefly, obviously. So there's another sector that I'm interested. So finance and economics.
Yeah.
So another sector, and now we're looking at these economical predictions in the year 2023 with this kind of sliding into recession. And again, what's going to happen in the near future? I mean, it's very uncertain and unclear for a lot of businesses and individuals and governments and everything, all that kind of turmoil that's happening right now, right? And in climate, adding that, again, climate change in the mix of that, and we're talking about a global disruption of economies potentially, right? And as I mentioned, impacting the human health and productivity, leading across different sectors and some of agriculture, forestry, tourism, and whatnot. So some of the numbers that I have here on the page, so it says that the largest impact of climate change is that it could wipe out up to 18% of GDP of the worldwide economy by 2050. So this is obviously some predictions, and we're looking at the temperature rise. If you're looking at the scale, and also have some metrics in front of me as well that probably will be included in a section underneath. If you're watching this on a YouTube, it's going to be in a comment section or in a podcast to find the link. Very interesting information, and this is information by the one of the Swiss giants, Swiss Re, which is a reinsurance company. They're based in Switzerland, and they're predicting that on a worldwide scale, 23 trillion by 2050. That's the loss that we're thinking that we might expect because of the climate change. So now on an economical aspect, I mean, those are huge numbers, even for me, hard to understand. I mean, to grasp even those numbers and understand how much damage we're actually talking about. But now coming back to again, your services. So question is, how much Earth observation data can help to identify and predict the economical consequences, right, of physical climate impacts for near-term and long-term forecasts, right? And then the second question that I have is how that data can be used to make better decisions in all these different sectors. Maybe you can use some examples.
Yeah, okay. So you've nailed why I don't sleep very well. Why I have so much gray hair, why my hair just tends to pop out randomly. Yeah, no, I mean those figures are staggering and they're certainly frightening. There's a world in which those are underestimates, right? Where the networking impacts of different collapses of different areas, cause sort of a network effect of downgraded environmental situations, economic situations. And I think what these numbers obscure in some ways are the individual stories, right? The people that are affected, largely marginal communities, right? Really impacted. And these are probably going to have, geopolitical impacts, right? I mean, you see them now with different droughts, different water stressed areas causing geopolitical chaos, immigration issues, right? So anyways, there's those numbers are really scary. They can be abstract. I think what's even scarier is if you start thinking about what that actually means to individual peoples, individual communities, individual countries. So, I mean, you've also nailed what I think is what we at Climate Engine really believe is one of the major blind spots in the economy today are those impacts, right? Again, it does us no good to, experience something, write a report, and then read about it 4 years from now, right? Part of these, these numbers like 2030, 2040, 2050 also obscures the fact that they're happening now, right? And if we can't learn to manage those risks today, we have no hope of managing them when it's a $28 trillion loss, or the numbers you had. So what we really feel our mission is to start thinking about this concept of resilience, right? And moving the concept of climate adaptation beyond just, hey, we got to build this bridge in this way, right? We need to build a wall here, right? And those are really, really important. Not to say they're not important. They're absolutely critical, but they're not sufficient, right? they're absolutely not sufficient, because where the real chaos is going to come from are the interactions of these events at global scales, at both global scales and hyperlocal scales, right? Concurrently happening all the time. So that's what really scares me. And that's really been the impetus in my mind for Climate Engine and working with Google. And they've been fantastic partners, working with them to understand, okay, this is not just a theoretical problem. This is an actual problem. This is a problem of data, right? This is a problem of computing, right? So it's not just, hey, let's do this run in 20, let's look at 2050, do a computer run, and then you have a static file. It's like, no. We need to monitor the planet every single pixel, every single day, and add analytics, right? Not only the Earth analytics, like what's happening to water, right? What's happening with drought, what's happening with wildfire risks, where are the flood risks, right? It's not just, that in of itself is a massive challenge. Run that globally all the time, right? With the best available science, but then linking that data to the financial system, right? Which assets are at risk? What do those assets do? How important is that asset, right? All those types of questions, all that needs to be integrated. Those assets themselves are constantly changing too. Who owns those assets? What do those assets do? What are the risk factors if this asset is at risk to this company, to that company? What do those companies do? How do they provide, critical infrastructure, critical pieces of product to a supply chain, right? So that's a massive computing challenge, the massive science challenge, the massive economic challenge. And really what we absolutely need to do, and I'm convinced of this, we need to pull those together, right? And we need to have that monitoring, and that data needs to be fed into the important levers of power, public sector, the consulting companies, the financial institutions, like companies, NGOs, all these different groups, right? This is something that is required infrastructure, right? It does us no good to focus on bridges and walls if we don't have this, and we don't learn how to use it, right? This is a new technology. It's a new way of thinking about things. So that's where I know, and this sounds really sad, to be honest. and this whole conversation we're having is extremely sad, right? It's almost too sad to even think about, right? It's kind of horrifying. But I think the good news in my mind is we collectively, and then coming back to my earlier point, we collectively can do this, right? We've shown we can make these changes, we can make these adjustments, right? We can build systems to adjust and be flexible to these risks. And I think that's where the Earth observation data, combined with the climate data, combined with the economic data, will give us hope to actually do that.
Perfect. So that's absolutely necessary, as you were talking about the collective approach and with the partnerships. So speaking about that, the partnerships and the collective approach, so how much have the scientific partnerships and third-party data providers helped Climate Engine to refine and provide the best available Earth observation data insights across the public and private sectors?
It's absolutely essential, right? So when we started, another sort of foundational principle that we thought was that there's no one company that's going to solve this problem, right? And we firmly believe that, right? You see a lot of companies and they're like, hey, we're going to do all these things, we're going to own these things, and it's going to be our little black box. Nobody can look at it, but we're going to tell you what these scores are, right? I think that's destined to fail. And any VC out there is listening to this, I apologize. But I think that's absolutely destined to fail, because there's no one company that's going to be able to do that, right? The science lives across institutions. It lives in government. It lives in NGOs. It lives in academia, right? So our approach has always been to focus on the best available science, whether it's ours or somebody else's, right? That we do our own science as well. But it really is about the best available science. It needs to be open. It needs to be transparent. The methodologies need to be transparent. It needs to be published, right? It needs to go through peer review because it needs to be trusted. So when we talk about third-party data, you know, it's we don't really differentiate between whether it's, you know, data that's coming out of our labs. You know, we have a division called, you know, Climate Engine Labs, which is producing science, or it's coming from a third party, you know, consultant or a different group, or it's published in the scientific journals, right? We don't differentiate between that. It's like what we're really trying to do is kind of build an open ecosystem where all these data sets and all these analytics can be fed into a system processed through the cloud, right? So another really key partnership is it's not just about the science, it's also about the computing, right? Because that is, I mean, it's a big problem, right? It's actually not as easy as most people would think, right? It's actually a really, really difficult computing, you know, computer engineer problem, computing challenge. So you know, it's having the insights, having the models, having the computing power to actually process those, and then having the ability to connect those to the economic assets. And that's really, really critical. So that's always been a foundational principle of Climate Engine. You know, we're a scientist-led company, and we take that really seriously. You know, I'm probably the world's worst scientist, which is probably why I'm the president of Climate Engine. You know, I have a Ph.D., but you know, it's not really the scientific aspect of publishing and stuff. Not really my bag. But you know, our team is primarily scientists, PhDs, and researchers, and it really, you know, it's a really foundational principle, and it's sort of one of my pet peeves with a lot of different groups, and you know, where they have a black box, right? It's like, well, just trust us. Here's the number. So, well, how did you derive that number? We can't tell you. That's our proprietary thing. Right there, we're lost. Instantly lost, because all we're doing is we're relying on branding. Oh, this came from these people, this came from these people, that we have to trust these brands, right? And now it's no longer science, it's marketing, right? Yep. And so that's a really important component that, you know, from the beginning we really hold dear to a value in the company.
So going back to the beginning, the foundation of your company since 2014, I mean, what's next? What's around the corner? If again, I don't know how long, how far actually do you look ahead as a company? If it's, you know, years, decades, or maybe even longer than that, in terms of the Climate Engine as a company, right? And I want to kind of put something out there, as you discussed today. You mentioned bridging the gap, right? So I want to ask you again, first of all, maybe you can answer the questions again, what's next there for you? And again, maybe if that ties in with bridging the gap, I want to ask, how big is the gap as we're talking about? Is that the gap in a supply chain? And you believe that there's a lot of companies that still don't understand on some parts of the supply chain of the value of EO, or how are you trying to fill in that gap with the Climate Engine in your company?
Yeah, okay, there's many questions there. Yeah, many loaded ones. I mean, the gap is massive. It's absolutely massive. The proof of that gap is that we are still increasing our carbon emissions. We're still losing rainforest, right? I mean, after everything we know about these risks, these things are still happening, and I honestly don't see them slowing down. I don't know about you guys, you know, there's efforts and there's move to renewables and blah, 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 blah. But, you know, look at the hard evidence. So they know our emissions are still increasing, right? It's not like we haven't known about climate change for decades. So that gap is absolutely massive, you know, and we need to fill it like as soon as we possibly can. So, you know, we talk internally about, you know, we need to build an economy as if we live on a planet. Right now, we don't, like, not even close. So you know, we need to start building that gap like as soon as possible. Otherwise, we won't have a planet that will sustain us. The planet will exist, and there'll be nature and there'll be things, you know, it's not like there's been, you know, 5 or 6 major extinction events over the course of planetary history. It's not like nature is going to go away, but is that environment something that we collectively can live on? That's a massive question mark. So when we're talking about these gaps, they're massive, and there's so many challenges. I can't honestly see our work ever being done. But in terms of where I think this work can go, I think this is a massive collective effort we all need to be involved in. And we all need to figure out how can we, bridge that gap between the economy and the environment. And ideally, how can we use data to do that? Right. And it's a really, really important, and I don't mean to sound pithy or whatever, like it's just some statement, but I honestly believe that if we can understand what's happening to the planet and attributing what's happening to the planetary systems, to the economic systems, right, we can start measuring those things. We can start actually implementing what we know how to do, right, is building different resilient systems, building different agricultural systems, building different management systems, so we can start adjusting to these chaotic events. That's what we need to do. So sorry, I know that's not a very specific answer.
No worries.
But yeah, I just can't. That gap is. I mean, it's always going to be there, and we always need to be working on bridging it.
So, Jamie, I have one additional question, but so sure. I'll just finish with that. So how do you think, in terms of, again, using AI to either manage those petabytes of data that we acquire every single day, to either merge the data sets, right, to provide a better data, or to even, as we're talking about, working as a collective and maybe conveying the message in a proper way, and kind of working as a collective on tackling these climate issues? How much do you think AI could help us with that?
Yeah, no, I mean, that's a really, really exciting area. There's, when we're talking about gaps, the way that we think about those gaps are the gaps of connectivity between environmental changes and economic activity, and vice versa, economic activity and environmental changes, right? So these are massive, massive, massive data sets on both sides. Right. So that's where I see AI being a really important tool, is starting to identify different patterns that we may not think of. Right. So looking at sort of butterfly effects of like, well, there's a drought here. There was an article I read, which was, it was meant to be kind of funny, but it was interesting. A drought in Oregon or something made the price of French fries in Japan higher. Right. So, these interconnected webs, I mean, they're so complex and so complicated. That's really where I think AI and ML processes can be really, really helpful, is starting to identify those and ideally start predicting these events, so that we can better manage supply chain, better manage agricultural productivity, from a public sector, better manage policy, and come up with ways to address these threats, before they happen.
Perfect, Jamie. So thanks for sharing the great insights and the perspectives on the subjects that are so vital today to be paid more attention. Obviously, there is attention, but it's never enough towards the climate change and its implications. But coming back to the point and the butterfly effect that you mentioned, right? So, so how can somebody, let's say, become your partner, or how can somebody get access your services so that they can, again, contribute towards a better future based on the effects it's a chain of the effects, right?
Yeah, no, absolutely. That's a big question too. So we do partner with various science organizations. And those partnerships honestly come from, nonprofits, academic institutions, as well as private companies, right? So that that's one area that we partner with folks. In terms of space technology, as you guys are well aware, and probably most people listening, that there's a massive increase in proliferation of microsatellites, of constellations. Those are really, to me, really, really another piece of really critical infrastructure. So we have partnered with several of those as well. and really trying to bridge in some ways the space data with the scientific community, with the use cases and the problem statements coming from the economic community, the public sector, these different sort of areas we talked about earlier, to start delivering analytics and really leveraging Google Cloud, cloud-based technologies to do that. So that's one area we partner in. We're always looking for geospatial data engineers. If there are any out there, please call me. It's incredible, just the computing challenges themselves, right? And there's, when we talk about filling gaps, I mean, that's a huge gap, right? There's actually computing gaps that need to be filled. So those are areas that we're actively pursuing in terms of new hires, getting new folks in the door. Yeah, and honestly, I think a lot of the work, and we start thinking about filling gaps, is identifying these use cases, right? And identifying where, not even identifying where these risks are, but identifying how companies, whether it's in the financial services, whether it's in, consumer packaged goods, whether it's in public sector, how they can use these insights within their own institutions, right? And that's much more of a sort of digital transformation type of question, but it's a really important one, right? So if you know where your risks are, if you know where your supply chain risks are as a company, what are you going to do about it, right? And that sounds like a kind of a simple question, but it's a massive one. And it really is about institutional change. So in any case, sorry, I know I give you long answers to your short questions. I apologize, but those are the areas where we really do work with a lot of different groups and a lot of different folks.
Okay. So thank you, Jamie, again for a lot of great insights. I mean, everything that we covered today, I mean, it gave us at least an insight now in terms of your company, what you're working on, and what the future is going to look like. Obviously, based on our conversation, as I said, it doesn't look that good, doesn't look promising. But look, if we have companies like Climate Engine obviously working on tackling this and providing the data solutions, right, in terms of decision making and kind of trying to predict what's going to happen in the near future, and maybe we can kind of shift that future into the good side, right? I think it's a beneficial, and just for us to have a conversation like that, there could be something brand new for a lot of people out there. They think that this is still in a discussion as like if it's going to happen or not. I mean, now we're facing the reality, right? And it's harsh, but it is a reality, right? And we as people, we're here. Our job should be to fix it, right? Do something about it. So again, we're very happy that that there's companies out there, like yours, who are working on these big problems. And hopefully today, by us doing this podcast, there's going to be more people who can contribute as partners, or more clients who can take advantage and use take part in your services and provide better services themselves.
Great. Well, thanks so much, guys. I really, really appreciate the time, and thanks all for joining. Very, very much appreciated.
Thank you, Jamie.
Thank you, Jamie. And thanks, everybody, for tuning in. If you were listening to this episode, we had today Jamie Herring, the CEO of Climate Engine, and to which we're very grateful for this insights that he shared. And we'll see you all on the next episode.